Welcome to the DIY Honda Garage channel. The DTC P0117 indicates a problem with the Engine Coolant Temperature (ECT) Sensor 1 circuit, which is vital for numerous engine management functions in the Honda Accord from the model years 2012 to 2017. Specifically, this DTC suggests that the voltage output from the ECT sensor is at a low level, signaling potential sensor failures or electrical issues. Located near the engine block, the ECT sensor plays a crucial role in monitoring the coolant temperature, allowing the powertrain control module, PCM, to adjust the air-fuel mixture, ignition timing, and idle speed for optimal engine performance. The ECT sensor operates by varying its resistance according to the coolant temperature. Normally, as the coolant temperature rises, the sensor's resistance decreases, causing a corresponding decrease in signal voltage detected by the PCM. When the PCM identifies a consistent low voltage output of 0.08 volts or less for a duration of at least 2 seconds, it triggers the DTC to warn of a malfunction. Understanding this DTC and its implications is essential for diagnosing and resolving engine performance issues linked to the cooling system. In conclusion, understanding the role of the engine coolant temperature (ECT) sensor is critical for managing vehicle performance and mitigating issues like DTC P0117. Recognizing the symptoms, such as the MIL illumination and engine performance issues, can prompt timely diagnostics, leading to quicker resolutions. The troubleshooting steps provided, ranging from checking for additional DTCs to inspecting sensor wiring and replacing faulty components, serve as a comprehensive guide to addressing this specific error code. Employing regular preventive maintenance practices not only can prevent such DTCs, but also enhance the overall reliability and efficiency of the vehicle. By staying informed about these maintenance methodologies and the importance of each component, drivers can ensure that their Honda Accord remains in optimal operating condition for years to come. The Engine Coolant Temperature (ECT) Sensor 1 is a crucial component in maintaining engine efficiency and performance. It measures the temperature of the engine coolant and provides real-time data to the powertrain control module, PCM. Located near the engine block, it plays a significant role in determining the proper mix of air and fuel entering the combustion chambers, ultimately affecting fuel economy and emissions. If the ECT sensor fails or experiences low voltage issues, the PCM will struggle to make accurate adjustments regarding ignition timing, leading to potential performance degradation. By continuously monitoring the coolant temperature, the ECT sensor ensures that the engine operates within the optimal temperature range, supporting overall engine management systems. Failure in this sensor can cause various problems, including rough idling or decreased fuel efficiency. Identifying the possible causes of DTC P0117 is essential for a structured troubleshooting approach. One potential cause is a short circuit to ground in the thermistor wire, TW line connected to the ECT sensor. This can lead to incorrect voltage readings, triggering the error code. Additionally, a failure in the ECT sensor itself can produce inaccurate readings or a complete lack of signal, causing the PCM to assume there is a malfunction. Another possibility is an internal failure within the powertrain control module, PCM, which could corrupt the processing of sensor data. It's important to note that the problems identified may not encompass all potential issues. Other electrical failures or mechanical concerns could also contribute to the DTC being set. To effectively resolve this error, technicians should systematically explore each possible cause until the source of the problem is identified and rectified. When DTC P0117 is triggered, various symptoms may manifest within the vehicle, signaling the need for immediate attention. One of the most obvious signs is the illumination of the malfunction indicator lamp, MIL, which alerts the driver to a detected malfunction with the engine management system. In addition to the MIL, drivers might experience poor engine performance, which can include rough idling, stalling, or decreased acceleration due to improper air-fuel mixture adjustments. Increased emissions may also be a significant concern, as incorrect temperature readings can lead to the engine operating inefficiently, thereby escalating harmful emissions. These symptoms not only impact vehicle performance, but may also result in compliance issues with emissions regulations. If any of these symptoms are present, further investigation into the ECT sensor and its associated circuits is warranted to prevent long-term damage to the engine. The first step in troubleshooting DTC P0117 involves conducting a thorough diagnostic review for related trouble codes. By checking for any additional DTCs that may be present, technicians can gather relevant information that might direct them towards the root cause of the current issue. After confirming the presence of DTC P0117, it's critical to analyze the freeze frame data stored in the powertrain control module, PCM, when the code was logged. This data can provide insights into the engine's operating conditions at the time of the malfunction. Next, technicians should perform a detailed inspection of both the ECT sensor and its associated wiring harness for signs of wear, corrosion, or damage. If any electrical problems are identified, they will need to be rectified before further testing is performed. This initial checklist will set the foundation for effective troubleshooting and aid in isolating problems related to the ECT sensor or its circuits. In the second step of troubleshooting DTC P0117, it's essential to directly test the resistance of the ECT sensor to assess its functional integrity. This involves using a multimeter to measure the resistance values while the sensor is subject to various coolant temperatures. Technicians will need to reference the manufacturer's specifications to determine what the acceptable resistance range should be for accurate functionality. If the resistance values are outside the specified range, this indicates a problem with the ECT sensor itself, leading to incorrect voltage output detected by the powertrain control module, PCM. Should the ECT sensor be found faulty, it must be replaced at this stage. After replacement, it's advisable to retest the system and clear the DTC from the PCM to confirm that the issue is resolved and that normal operational parameters have returned once the vehicle is back in service. This direct approach not only addresses the immediate concern, but ensures that the vehicle runs efficiently. The third step in addressing DTC P0117 involves inspecting the connectors of the powertrain control module, PCM, which may play a crucial role in the communication between the ECT sensor and the engine management system. Technicians should check for any signs of corrosion, bent pins, or loose connections that could disrupt the signal transmission from the ECT sensor. Corrosion can create resistance in the electrical circuit, leading to incorrect voltage readings being sent to the PCM. If problems are detected, corrosion should be cleaned and any damaged components must be either repaired or replaced to ensure a solid connection. After addressing any connector issues, it's vital to reconnect the PCM properly and perform a functional test to validate that the repairs were effective. This thorough inspection not only aids in resolving DTC P0117, but also helps ensure the reliability of the engine management system going forward. To conclude the troubleshooting process for DTC P0117, it's essential to perform a final repair verification. First, clear the DTC from the Powertrain Control Module, PCM, using an appropriate scan tool. This step will reset the system and remove any stored trouble codes. Following this, a comprehensive test drive should be conducted to monitor the vehicle's performance under various operating conditions. While driving, watch for any indications that the engine management system is functioning correctly, particularly with regards to temperature control and engine responsiveness. If the DTC does not reappear after several drive cycles, that is a strong indication that the issue has been effectively resolved. Documenting the results of this verification phase reinforces the reliability of the repairs made, ensuring long-term vehicle performance and satisfaction for the owner. Preventive maintenance plays a pivotal role in avoiding reoccurrences of DTC P0117. Regular inspections of the engine coolant temperature (ECT) sensor and its associated wiring can help identify potential issues before they escalate into significant problems. Technicians should periodically check the condition of the ECT sensor for any signs of wear, damage, or corrosion that could affect its performance. Maintaining wiring integrity is equally important, as frayed or worn wires can lead to shorts or open circuits, triggering DTCs. Additionally, keeping the connectors clean and free from corrosion will ensure reliable communication between the ECT sensor and the Powertrain Control Module, PCM. By implementing these preventive measures, owners can enhance the longevity and efficiency of their vehicle's engine management system, significantly decreasing the likelihood of encountering similar diagnostic trouble codes in the future. Please like and subscribe to the channel. See you next time.